Bismillah ar-Rahman ar-Rahim. Alhamdulillah. Wassalatu wassalamu ala Rasulillah. We continue strategy of integration exercises about section 7.5. We reached question 11. Continue with question 16. All the questions here are evaluate the integral. Well, to solve this question, we know when we have t times sine or t times cosine, we use integration by parts. So here I know that sine 2t is equal to 2 sine t cosine t. So I think it would be nice if we write it t times sine t cosine t. I can write it half sine 2t. And now you can continue easily and use integration by parts. So if I take u equals to t, then du would be dt, and dv, if I take it sine 2t dt, then the integral of sine is negative cosine 2t over 2. And then integral v du would be easy, just integration of negative cosine 2t. Here we have rational function. So if we factor the denominator, we have x plus 4 times x minus 1. So 4 minus 1 is 3, yeah. So we just write it as x plus 2 over these two would be equal to a over x plus 4 plus b over x minus 1. So it's a typical question about section 7.4. We find a, b, and we find the integral easily. Here, the derivative of 1 over x, if we take u equals 1 over x, then du would be negative 1 over x squared. And now this integral can be written as also, of course, dx. So cosine 1 over x, we call it u. And now x cubed, I need a negative sign here. So there will be a negative sign outside. Negative 1 over x squared dx. I'll be take it as u. And now I have x here. X cubed can be written as x squared times x. So there is one x remaining. And I can solve this for x. X is in fact 1 over u. So just a minute. Yeah, negative 1 over x squared dx is du. Okay, let me write it for you in an easy way, a nice way, so you understand it. So this is negative cosine 1 over x, and I have x times x squared dx. So the integral would be negative integral. Now the negative sign with x squared with the dx, all of this is du, isn't it? So I will have cosine u, okay, over all of this is du, and I have x. X is 1 over u, but 1 over u, I can write it u cosine u du, okay? And I continue using integration by parts. Well, here x squared minus 1, so I can take x as secant theta, and I can continue using section 7.3. dx is secant theta tan theta d theta, and the square root of secant squared minus 1 is just tan theta. So I will have 1 over secant cube theta tan theta, secant theta, tan theta, d theta, and it would be integral cosine square theta d theta. I write it as 1 plus cosine uh, 2 theta over theta, and I continue easily. Okay. Here I have a rational function. So I can immediately write 2x minus 3, factoring the denominator, taking x as a common factor, and then I write it a over x. This is an irreducible quadratic factor, so I write it bx plus c over x squared plus 3, and I use the method in section 7.4 to continue the integral. Here 1 over cosecant is sine, so if I just write it cosine cube x times sine x, then I can take u as cosine x, and du would be negative sine x dx. So it would be negative integral. Now negative sine dx, sine x dx is du, and cosine cube would be u cube, and I continue easily. Len alone, I have to use integration by parts by taking u as len 1 plus x squared, and then du would be 1 over x squared plus 1 times 2x, the derivative of x squared plus 1. And dv is dx, v is x. Now this would be uv minus integral v du. If you multiply v times du, I'll have 2x squared over x squared plus 1 dx. And now this integral, I can solve it uh, using long division because I have x squared up and x squared down, same degree. So if I divide 2x squared by x squared plus 1, then 2x squared plus 2, and I have negative 2 here when I change the signs. So I can write this integral 2 minus 2 over x squared plus 1 dx. And then the answer would be 2x without integral, that's it. Minus times minus would be plus 2 tan inverse x plus c, and do not forget to put uv here. Well, I have 1 minus x squared, so I can take x equals sine theta using trigonometric substitution, and then dx would be derivative of sine theta is cosine theta, and the integral would be x squared is sine square theta, square root of 1 minus sine square, cosine square, so square root, I will have cosine theta, and this is cosine theta d theta, and it would be integral sine square theta d theta. And do not, of course, it's 1 minus sine 2 theta over theta. Do not forget to change values from x to theta and put them here. Of course, you find theta. Theta is sine inverse from here. Theta is sine inverse x. So if x is 0, sine is 0, and so on. This is an easy question. If you just take u equals square root of t, then du would be 1 over 2 square root of t dt. So it would be 2 times integral eu du. And just don't forget to change the numbers from t values to u values. If t is 1, u is 1. If t is 4, u is square root of 4, which is 2, and you continue easily. Here, notice that 1 plus e to the power 2a is constant. So you can just take it out of the integral. And the integral of e to the power x is e to the power x. So that's it. That's the answer. here I can take u equals ln x. I can do it in two steps. I can take u equals ln x. So du would be like this. And then the integral would be integral of u, and 1 over x dx is du, and this is 1 plus u square. And then you do another substitution. You take t equals 1 plus u square, and dt would be 2u du, and then the integral would be half 2u du is dt over square root of t, and you find the integral easy. Or you can here think of taking u equals 1 plus ln x all square, the radicand. You just take it u, because when you find du, it would be derivative of ln x to the power 2 is 2 times ln x to the power 1 times 1 over x dx. And this is exactly what you have here inside the integral. So ln x over x dx times 2, and put half here, you will call it du, and 1 plus ln x squared is just square root of u, and this is exactly the same integral here. And you continue and find the answer. Well, here I have to take u equals 1 plus square root of x. All right. If I take u equals 1 plus square root of x, we see what happens. Du would be, but I want to change from u to x. So I need to solve this equation for x first. So u minus 1 would be square root of x, u minus 1 square would be x, and 2u minus 1 du is dx. So 1 plus square root of x is u to the power 8, and dx is 2 times u minus 1 du. So the integral would be 2 integral u to the power 9 minus u to the power 8 du, and just change the numbers from x to u. So if x is 0, u would be 1. If x is 1, u would be 2, and you find the integral easily. This is u to the power 9. This is question 131. Here I have a rational function, and the power of the numerator is equal to the power, the degree are equal, so I use long division. Immediately, long division here will solve the question. So 12, write it in standard position. 12t plus 1, we divide by 3t plus 1. 12t divided by 3t is just 4. Changing the sign and add, I'll have negative 4. So I immediately can write this as integral of 4, the quotient, minus 4, the remainder, over 3t plus 1 dt. And this would be, of course, yeah, here I have the same number, 0, 1. So the integral would be 4t minus 4. Now integral of 1 over 3t plus 1 is ln 3t plus 1 over 3. All of this from 0 to 1, and you find the answer. This is a rational function. We need to factor the denominator. We can factor the denominator using grouping because we have 4 terms. So if we take x squared from the first 2 terms, we will have x plus 1 and x plus 1 also here. So now I can take x plus 1 as a common factor, and I'll have x squared plus 1. So I can write this rational function as a over x plus 1, and x squared plus 1 is an irreducible quadratic factor. So I put bx plus c here, and I find a in our quick way, and then multiply and find b and c and find the integral easily. Section 7.4. Well, in question 35, uh, let me take u as 1 plus e to the power x. Let us solve this equation for x. And now I take the derivative. So derivative of ln u minus 1 is 1 over u minus 1 du, and derivative of x as dx. So now I can write it as dx as du over 1 over u minus 1, and 1 plus ex is just u. So this is immediately can be written as a over u minus 1 plus b over u. Find a and b rational function, section 7.4, and continue the problem. Here I have 10 to the power 3. So this is typical section 7.2. It says take u as secant theta, and then du would be secant theta tan theta d theta. 7.3, sorry. This is section 7.3. And now I write tan cube. I take one tan out. I have tan square left. Tan square, I write it secant square theta minus 1. And secant square, I have 1 secant, and I take the other secant out. With the tan, I took it from tan cube. And now the integral would be u square minus 1 times u du. And you just need to change the values from theta to u. And notice here, I do not have secant inverse u in the calculator, so u equals secant theta. I will write it 1 over u equals cosine theta, and then theta would be cosine inverse 1 over u. And now you put 0. If theta, no, okay, that's, we don't have to do this one, because immediately here theta is this is section 7.2, not 7.3. Theta is 0, so you find secant 0. Secant 0 is 1, and because cosine 0 is 1, and secant pi over 4 is 1 over square root of 2. Cosine pi over 4 is 1 over square root of 2, so secant would be square root of 2, and you continue easily. So this is section 7.2, sorry. Well, here, let me simplify. So I have sine theta, and 1 over secant is cosine theta, and cotan is cosine theta over sine theta. So it is just cosine square. And cosine square, you write it as 1 plus cosine 2 theta over theta, and you continue easily. Well, here, look carefully. You find that we have secant tan in the numerator and secant in the denominator. So if I just take u equals secant theta, then du would be secant theta tan theta d theta. So secant theta tan theta d theta is du, and secant square is u square, and secant is u, and you just write this u times u minus 1, and then use section 7.4 to continue. So a over u plus b over u minus 1 du. Find a and b and continue easily. Well, here, 53, I have 1 plus square root of x. So I think you can try taking u equals 1 plus square root of x. It will work. And also you can take u equals square root of x. Both will work. So let me find this quickly. I need to change everything to u. So I will solve it for x, and then 2u minus 1 du is dx. So it would be integral x. Now what is x? X is u minus 1 square. All right. And 1 plus square root of x is just u. And dx is 2 times u minus 1 du. So it would be integral 2 times u minus 1 to the power 3 over u du. And that's easy. You just find the cube of u minus 1. It's u cube minus 3u square plus 3u minus 1 over u. And then you divide, you write it u cube over u, that's u square, minus 3u square over u, that's 3u, plus 3u over u, that's 3, minus u inverse, and you find the integral easily. If you take x equals or u equals square root of x, then u square would be x, 2u du would be dx, and the integral would be x is u square over 1 plus u, and dx is 2u du. So it would be integral 2u cube over 1 plus u du. You use long division and continue easily. Long division here, if you divide 2u cube by u plus 1, you will have 2u square, 2u cube plus 2u square, then here minus 2u square minus 2u minus 2u square minus 2u plus 2u, so plus 2, 2u plus 2, and then the remainder would be negative 2. So you can write it as 2u square minus 2u plus 2 minus 2 over 1 plus u or u plus 1 du, and this is an easy integral. 57. Let me take u as square root of 4x plus 1. Then u square would be 4x plus 1, and then 2u du would be 4 dx. So the integral would be, well, dx is 2 over 4u, so it is half u du. That's dx. And x, I can find it from here. X would be u square minus 1 over 4. And the square root is just u. U cancels with u, and this 4 will go up, so I'll have 4 over 2, which is 2, and I'll have du over u square minus 1. And this is easy. You write it u minus 1 times u plus 1, then a over u minus 1 plus b over u plus 1, section 7.4. Well, here I will take u equals square root of x, then du would be, no, I do not do it like this. I solve it first for x. U square would be x, and then 2u du would be equal to dx. And then the integral would be 2u du. This is a rationalization substitution. X is u square plus x is u square times u, so u cube. So if I take u as a common factor, I'll have u plus, let me take u square as a common factor then. So I'll have 1 plus u. And now I can cancel the u with one of these two, so I will have 2 du over u times u plus 1. And you just write it a over u plus b over u plus 1 and continue like section 7.4. This is the same. So I'll do the same substitution, but the integral would be dx is 2u du, and square root of x is u, and x u squared times square root of x, so u cube. So the only difference should be u plus u cube instead of u squared plus u cube. So here, if you take u as a common factor, you will have 2 du and 1 plus u squared. And this is just 2 tan inverse u plus c, and you write u as square root of x. And that would be the answer of the problem. Well, here, x to the power 4 minus 16 is factored into x minus x squared minus 4 times x squared plus 4. And then x squared minus 4 can be factored into x minus 2, x plus 2, and x squared plus 4 is an irreducible factor. And now you solve this. Continue like section 7.4, find a, b, c, d, and then find the integrals. Well, here I have 4x squared minus 1. So I take 2x equals secant theta, section 7.3. And then 2 dx would be equal to secant theta tan theta d theta. And this integral would be, well, I need 2 dx, so let me write here 2. And here I have secant theta tan theta d theta. And x squared is secant square over 4, secant square theta over 4, and square root of 4x squared minus 1 would be square root of secant square minus 1 tan square, that's tan times tan. So tan cancels with tan, 4 will go up, this would be 2, 4 over 2, and secant will cancel with secant square. I'll have 1 over secant, which is just cosine, and then it's easy to continue. Well, let us take here u equals square root of x. Then we don't do it like this. We solve it for x. This is the rationalization, not a usual substitution. So 2u du would be dx. So square root of x is u, e to the power u, and dx is 2u du. So it would be 2u squared e to the power u du, and we use integration by parts. Quickly, you put, this is the function, make the table very quick and find the answer. Well, here I'll take u equals square root of x plus 1. And then to solve it for x, I will have u minus 1 square equals x, and then 2 times u minus 1 du is dx. So this would be 1 over integral of square root of u, and dx is 2 times u minus 1 du. So it would be 2u minus 2 over square root of u du. You just divide 2u over square root of u over square root of u to the power half, minus 2 times u to the power negative half, and you find the integral easily. Well, here I write sine 2x as 2 sine x cosine x dx. And then I take u equals to cosine square x. Du would be 2 cosine x times the derivative of cosine, which is negative sine. That's 2 negative 2 sine x cosine x dx. So I have a negative sign, and negative 2 sine x cosine x dx is du, and here I have 1 plus u squared, because cosine to the power 4 would be u squared. So it is negative tan inverse u plus c, or negative tan inverse cosine square x plus c. Well, here, if you think of this problem, there is no way to deal with it. But if I just multiply by the conjugate, because you have two roots, then I will have square root of x plus 1 minus square root of x over. Here, if I multiply these two, I have x plus 1 minus x. And x plus 1 minus x is just 1. And now you can continue easily, because the integral of x plus 1 to the power half and x to the power half is just x plus 1 to the power 3 over 2 times 2 over 3 minus also 2 over 3 x to the power 3 over 2 plus c. Here, if I take x cubed as u, then du would be 3x squared dx. I have x squared, so I need 3 up, and 1 over 3 would be outside. And then I'll have du over x to the power 6 would be u squared. X to the power 3 is u. And that's it. I can factor this u plus 1 times u plus 2. And then I can write it as a over u plus 1 plus b over u plus 2 du. I find a and b, and then the integral. If I take u equals e to the power x here, then du would be ex dx. I have e to the power 2x. So let me write it like this. So I will have ex is u, ex dx is du, and here 1 plus u. And I use long division, and I continue easily. You must be able to use long division by now. So u over u plus 1, 1 u plus 1. So I have minus 1. So it would be integral 1 minus 1 over u plus 1 du. So it is u minus ln u plus 1 plus c. And please replace u by e to the power x. Well, here I have ln x plus 1. In fact, it's multiplied by x minus 2 to the power negative 2. So I use integration by parts. I take u equals ln x plus 1, and du would be 1 over x plus 1 dx, and dv would be x to the power negative 2 dx, and v would be x to the power negative 1 over negative 1. And the integral would be uv minus integral v du minus this minus will be multiplied, would be plus, and this is 1 over x times x plus 1. So you just write it a over x plus b over x plus 1, and you continue as section 7.4. Well, here I can take, this is sine inverse. So I can take also here 1 minus x squared. I can solve it in two ways actually. I can take u equals sine inverse x, and then du would be du would be the derivative of sine inverse, which is 1 over square root of 1 minus x squared dx. And then this integral would be, what is x in this case? X is sine u. So I'll have sine u plus sine inverse x, which is u, over nothing, because 1 over square root of 1 minus x squared dx is just du. And you know integral of sine u and integral of u. Or if you take u as, or if you take, sorry, x as sine theta using section 7.3, so then dx would be cosine theta d theta. And then the integral would be integral of x is sine theta, sine inverse x is just theta, and square root of 1 minus sine square is square root of cosine square, which is cosine, and dx is cosine theta d theta, and then you have integral sine theta plus theta d theta, which is exactly the same as this. Here we write it, we divide, so we write it 4 to the power x over 2 to the power x plus 10 to the power x over 2 to the power x dx. And remember, when we have a over b to the power r, we can write it a over r e to the power r over b to the power r. So we can write this actually as 4 over 2 to the power x, 10 over 2 to the power x. And then 4 over 2 is just 2 to the power x, and this is 5 to the power x. And the integral of 2 to the power x is this one, and the integral of 5 to the power x is this one, and that's the answer. The last question, if I take x as a common factor, I will have ln x minus 1. And if I take u as ln x minus 1, then du would be 1 over x dx. And this integral would be du over u, and you know how to continue. Thank you very much. Hope you enjoyed studying integrals, and good luck.